Welcome to KB Career Point. Now we are going to see Coulombs law. Coulombs law, what it is explaining to us. It is a small definition, but it is a valuable definition for us to do calculations and to move the further steps. Okay, very important concept. Coulombs law, what it is telling us, force between 2-point charges is directly proportional to the product of the magnitude of the two charges. What just you are reading like that, don't tell me. Listen here. Force between 2-point charges. 2-point charges what? Let's we will take Q1 and Q2. Okay. 2-point charges. What is the force is acting between these two things? If both of the charges are having same symbol, that means positive means then force will be repulsive. If the two charges are having the same, suppose if it is negative, same symbol, that time also repulsive. If the two charges are having different symbols, one is in positive, another one is in negative, that time it will be attractive. Attractive force is acting on this one. So, same charges, same magnet, same things, that means the same symbols. Plus, minus that will repel each other, and plus and minus will be attract each other. This is the concept of the Coulombs law. So force between 2-point charges, this 2-point charges force, it is attractive or repulsive based on the charge what they kept there. And how we calculate this one means force between, how we calculate force between the 2-point charges is directly proportional to the product of the magnitude. Directly proportional to the product of the magnitude. The magnitude means the value of the charge. Okay, suppose it is 5 coulomb, the given means 5 is the magnitude. So Q1 into Q2 directly proportional, and the force is inversely proportional to the square of the distance. The force is inversely proportional to the square of the distance. Suppose these two charges kept between some distance. They are using some distance there, some distance they kept there. Okay, that distance we are keeping as, suppose for example Q1 and Q2, we are keeping in some distance R means, so force is inversely proportional to R square. Inverse means denominator, proportional to the square of the distance between the charges. Okay, now we will combine and write this one, that time we will get Q1 by Q1 and Q2 will come up and R square will come down. To remove this proportionality symbol, we are introducing one value, that is one constant, that is called as K. K value is, K how we can write means, K we can write as 1 by 4 pi epsilon naught. Epsilon naught is the permittivity of free space. It is having one value also, epsilon naught, that we will see, and 1 by 4 pi epsilon naught also together having value, that also that we will see. So force is K Q1 Q2 by R square. So we can write this as 1 by 4 pi epsilon naught Q1 Q2 by R square. This is the Coulombs law. It is telling force is directly proportional to the magnitude of the product of the magnitude of the two charges and inversely proportional to the square between the square of the distance between the two charges. If they are asking me, just you write like this one only. This is enough for us. With this thing, what is force for unit SI unit Newton only? No, same Newton only, here also Newton. Force SI unit is Newton, here also Newton only. How much it is coming there? Okay. So epsilon naught value is 8.85 into 10 power minus 12. The SI unit of epsilon naught is c square n minus 1 m minus 2. And this epsilon naught, how we are calling this one means permittivity of free space. Then the 1 by 4 by epsilon naught also together having one value 9 into 10 power 9. Always we used to use this value only for our calculation purpose. So F is what? Force is 1 by 4 pi epsilon naught Q1 and Q2 by R square. Okay. So epsilon naught only we need. So bring the epsilon naught here. So epsilon naught is equal to 1 by 4 pi F Q1 and Q2 by R square. What is the value of SI unit of F means Newton. And what is R square? R means distance between the two charges. Distance between the two charges. So we are representing the distance always in meter. So meter. How much meter? 2 meters. So meter square. This charge we are representing in coulombs. So 2 coulombs are the so coulomb square. So that only it is coming as a SI unit. Coulomb square Newton minus 1 meter minus 2. Similarly, this also you will get Newton meter square by Coulomb square. If you forget this SI unit also, we can derive from the formula itself. Force formula is force unit is what? Newton. Okay. So keep that 1 by 4 pi epsilon naught here itself because this is only we are coming to identify. Then Q1, Q2 will come down. Q1, Q2 will come down. R square will go up. Okay. So R square unit is what? Meter square and force is Newton. And this one is Coulomb square. We reached now SI unit. So SI unit we can derive from the formula itself if you know the basic SI units of this one. Okay, basic quantity SI unit if you know means we can derive from that the SI unit directly from the formula itself. Don't need to study separately this one. Clear? Okay, so force formula is what? 1 by 4 pi epsilon naught Q1 Q2 by R square. This is the Coulomb's law it is representing. And this is only the permittivity of free space, that means it kept in air. If suppose we are going to keep this in some medium, some water or some other glass, something we are going to keep means that time you have to use this epsilon naught as ER. Any other medium, okay, ER. So this is any medium we can use, medium, okay. So this is also medium, force medium. Some medium we are using means that time medium we can use. So that also we can represent like the same formula, only we are instead of epsilon naught we are using a epsilon medium. We can check the ratio of the medium. F medium by F original formula, that is in the free space, that is 1 by 4 by epsilon naught Q1 Q2 by R square by 1 by 4 by epsilon naught Q1 Q2 by R square. Remaining everything is same only. So this will go. This denominator will come as reciprocal. So that time it will come as 4 by epsilon naught by 4 by epsilon naught R. 4 by 4 by will cut. It will come as epsilon naught by epsilon R. So F force in the medium by force in the air is equal to epsilon naught by epsilon R. This is the formula. Reciprocal, that means oppositely will come. Air here down, here air will up, and air in the medium will up, here medium will down. Because when you are doing this denominator, at that time reciprocal will come, automatically epsilon naught will come up. Okay. So epsilon naught by epsilon R. Okay. This is the thing. This we are representing as K. K, because medium is there, no, dielectric constant K that we are representing as K. Epsilon naught by epsilon R is equal to F medium by F. K is called as dielectric constant. Now the Coulomb's law, how we are going to apply in the concept that we will see. Suppose we are having two charges. One is Q1 and another one is Q2. The symbol of this one is same. Okay? Symbol is same, so it is going to repel each other. How the repulsion will come? What is the force in this one means? What is the force of Q1 means? The force of Q1 is based on Q2 only. So Q2 is going to act on Q1. So the Q2 is not allowing the Q1 force to come towards it. So it is going to come in this direction, repulsive. Similarly, the Q2 what it will do means Q1 is going to act on Q2 Both of them same symbol. So what it will do? It will repel that side. Repulsion. So F21. They are repelling each other. So F12, what is this force of F12? That is exactly opposite to the force of F21. Opposite. Okay, so it is repelling each other. Similarly, this how we are representing this negative means in the formula F is equal to 1 by 4 by epsilon naught Q1 Q2. The distance between that one is R, so R square. We are representing that in unit vector. This is representing direction. We are not writing plus or minus in this Q1 and Q2, only the direction oriented only we are telling there. If they are repelling each other means that time the net force we are calculating, and this repulsive we are writing as repulsive force. Repulsive we are calculating, we are seeing that it is repelling each other, so we are writing repulsive force. Okay, for example, suppose 5 coulomb and 3 coulomb is there, means we are writing 1 by 4 pi epsilon naught. 5 into 3 by the distance between that one, for our convenience I am taking 2 meter. So 2 square. Okay. So this 1 by 4 by epsilon naught we will write as 9 into 10 power 9. 5 3s are 15. 2 2s are 4. Further calculation, after calculating, one final answer will come no. So now we are going to give the answer as what is the net force acting on this one means. Net force is what? Repulsive force. Clear? Similarly, another concept we are going to see means same only will come for negative also. Both of them if negative charges means that time also same, it will repel each other, same concept only will come. Okay, repulsive force only we are going to write that. Suppose one is in positive, another one is in negative, and the distance between that one is R. This time it will be attractive force. We are going to give what is the net force acting between this one means it will be attractive because opposite forces we are writing there. So how we are going to give that one? This one, suppose 5 coulomb, same thing we will take minus 4 coulomb means we are not going to use substitute the negative because force is a vector quantity. Keep in mind force is a vector quantity. So F is equal to 1 by 4 by epsilon naught Q1 into Q2 by R square. The distance same will give us 2 meter. And the R should be in meter only, not in centimeter. Suppose if it is in centimeter means 2 centimeter they given means 2 into 10 power minus 2 meter is substitute there. This is easy for us. Instead of doing decimal, do this one, keep in mind. Now we will do this one 1 by 4 pi epsilon naught 5 into 4. No, don't write minus 4. No need to write minus 4 because it is the vector. So only 4 is enough. By 2 into 10 power minus 2. But here we kept in meter only, no? Okay, 2 into centimeter will give. Centimeter will give. So 2 into 10 power minus 2, the whole square. And what is the n cap? N cap is representing what is the n cap? Because it is n cap we are doing. N cap is what? It is attractive force. Now this one, this is 9 into 10 power 9, fixed value 20 by 4 into 10 power minus 4, give this one. 4 5s are 20, 10 power minus 4 is coming up, it will be 10 power plus 4. Okay, so 5 9s are 45, after calculating you are getting 45. 45 into 10 power 13, it is what? In the n cap part, what you are going to write? It is attractive. So, attractive force. Clear? This only we are going to do in this one. These two charges is there. So, this is enough for us. Like this, only one attractive and repulsive we are going to do. Suppose more than 2 charges are there. That time we are going to calculate attractive and repulsive for each charges, each two charges. Then we are going to give net charge in this one. Okay. So that is system of charges we are going to do. Now Q2, Q3, Q1, like this 3 charges are there. How the net charge is going to calculate from this one we will see. That is only superposition of electrostatic forces. The superposition principle we are going to use. So how to do means Q2 is going to act on Q1. Both of them same symbol only. So it is repulsive. How where the Q1 will go, where this one will go means it will act on this direction. Okay, so this one will be F1, 2. In this position only we are seeing. Okay, so this will go in this direction. Now Q3 is going to make this, going to act on this Q1. Where the force will go means this, the force will be go like this because it is repulsive. If it is attractive means, how we have to represent it? It will come like this, attractive together. Okay, it is attractive means if Q1 only we are going to calculate means Q1 will show like this attractive symbol because it is coming towards, force is coming towards. Now what is happening in this? We are pointing the Q1 only. So Q3 is going to act on Q1, so it is going to repel that one. So F13. And Q2 is going to act on Q1. This is what both of them positive. Q1 point only we are representing. So Q1 force is going in this direction, that is F12. What is the net force of this one means? Net force will be one is going in this direction, another one is going in this direction. So we will call our grade 11 vector concept. So that is it will go. Okay. Net force will be in this direction F1. How to use the formula? What is the formula? F1 square, F12 square. There we studied two different concepts like this is two direction it is going means if it is 90 degree is there means only we will write this one as suppose A and this one is A1 and A2 means A1 square plus A2 square we will write root. If it is 90 degree. If some other time means other angle it is going means that time we will use A1, A2 cos theta. Okay, so this is the net force acting, net vectors and property that only we studied, that only the same only here also we are going to use F12 square, F13 square plus F12, F13 cos theta 2. Okay, 2 will come. Cos theta, what is the angle? Based on this one we will calculate. This is the superposition principle. Now we are seeing means this is the charge Q naught is here. Now we are going to calculate, we are going to do that superposition principle. What is the total charge of this one which is going to act on, what is the force on this Q naught we are going to calculate. Net force on the Q naught, electrostatic force on Q naught we are going to calculate. So first we will identify the direction where it is going. So see here Q2 and Q naught same positive only because negative we cannot able to see. So it is repulsive. So Q2 make that Q naught force to go this direction. Not allowed to come towards it. The Q2 what it is doing? Kicking this side. So it is coming here. So F02. Force acting on the knot Q naught by Q2. Then this Q1 this is Q, so Q1 we are checking means Q1 also same only that the symbol you are seeing means positive. What it will do? It will not allow that Q naught force to come towards it. So it is also pushing that side. So repelling. Clear? Now this Q3 you see, Q3 what it will do? The same thing only, not allowing the force here, this force. If it is trying to come here means it is keeping go that side like that, it is telling so F03. And Qn like this, lot of charges are there, Qn is going to act on this one means we will go F0n. Okay, so now how we are going to write this one means in that for Coulombs law F net is equal to 1 by 4 pi epsilon naught. For this one F02 is, first we will start from F01. F01 is acting on Q1 and that means Q0 and Q1 only involving this two charges only involving here. So we will write Q0 and Q1 by the distance between that one is R01 we are keeping means so R01 square. and we are telling that direction, which direction? That is only direction. So if it is attractive or all the arrows are coming together means we will put plus. If the arrows are going in the opposite direction means minus we will put. Here all are different direction. Okay. So that we have to calculate the net vector sum only we have to call again. Here R naught 1 cap plus this is representing the direction only. Next 1 by 4 pi epsilon naught. For this F02 we are taking means Q0 and Q2, the two charges acting on this force. So that we write. And the distance between that one is R02 we are keeping means R02 square and R02 the cap, the direction. Like this we will write 1 by 4 pi epsilon naught. Now we are writing F0 n means these two charges acting there. So here Q0 and Qn by the distance between that one is R0 n we are keeping means R0 n and R0 n cap. This is the superposition principle. How many charges are there also no problem. We will find it is repulsive or attractive and we will combine that one. Okay.